Section 21.2, Earth's internal layers. So it wasn't until 1906 that the core of the Earth was first discovered to be there. And this was done after observing a large earthquake in India. The P waves were measured to move through the Earth, and the S waves didn't, which implied there was some type of liquid in the center of the Earth. And then a few years later, the boundary between the crust and the mantle was found. This boundary between the crust and the mantle is known as the Mohorovic discontinuity. Pronunciation's probably not correct. And then by 1936, we had found all four layers of the Earth. Figured out that the core was there first. Then he discovered that there's a link between, or a boundary between the crust and the mantle. And then by 1936, they figured out that there's two layers in the core. So starting from the inside of the Earth and making our way out, the core of the Earth is mostly metal. It's composed of iron, mostly iron, and some nickel. The inner core is solid because there's just a lot of pressure around it that keeps that solid metal from melting. The outer core has much less pressure on it. So the outer core is liquid. It is a liquid metal of mostly iron. The outer core moves. It flows at a rate of a few kilometers per year, but it moves. It flows around the inner core. And the motion of that liquid in the outer core is what generates the Earth's magnetic field. Iron is a magnetic atom, and when it is moving, it'll generate a magnetic field. And Earth's magnetic field is extremely important to human existence. It protects us from radiation from space, which without the magnetic field would give us all cancer and kill us. One step up from the core is the mantle. The mantle is approximately 2,900 kilometers thick and is by far the biggest part of the Earth. It makes up about 84% of Earth's volume. So most of the Earth is the mantle. It has some relatively uniform composition, but it's mostly hot silicate rocks that act like an elastic solid, kind of like Jello. In some parts of the mantle, the rocks even flow even if they are solid. They move with the rest of the mantle. Studies of seismic waves have shown that the mantles can be split into two different regions, the lower mantle and the upper mantle. The lower mantle is almost completely solid, and it extends from the core to about 700 kilometers from the surface. Above that is the upper mantle. And here's where the separations get a little more vague, I guess is a good word to use. We can divide the upper mantle into two different regions. The lower part of the upper mantle is what's known as the asthenosphere. It's mostly solid, small amounts of liquid rock, but here that region flows easily with convection currents, so that as cooler, more dense rocks sink, they are warmed and expand and become less dense, and then float back up, and you generate a convection current. Above the asthenosphere is a region known as the lithosphere. The lithosphere accounts for not only the upper part of the mantle, but also the entirety of the crust above it. So the lithosphere isn't just the upper mantle, it's the upper mantle and the crust with it. It is the part where the humans and the things are. We live in the lithosphere. The lithosphere is rigid, it doesn't move, and instead floats on top of the asthenosphere and the convection currents that exist there. Because the motion of the mantle is not uniform, it doesn't all move in one direction all at once, the lithosphere is broken up into pieces, and those pieces are known as plates. And even though those plates move, and they move really slowly, they account for all of the earthquakes and the volcanic activity and the mountain formations that occur on the Earth. And we're going to talk about how that occurs in the next few sections. Finally, if we just want to focus on the crust is essentially the top part of the lithosphere. Right? So the lithosphere contains the crust and this upper part of the mantle, or the upper part of the upper mantle. The lower part of the upper mantle is the asthenosphere. And then you have the solid lower mantle down at the bottom, the liquid outer core of liquid metal, mostly iron, and then the solid inner core. When we talk about the crust on the Earth, we divide it into two different types. We have oceanic crust, which is underneath the ocean, and it's much thinner and more dense than continental crust, which is above the ocean, above the water. Of course, not all continental crust is going to be above water. It can extend out into the water a little bit. But in general, you see that the continental crust is where the actual land masses stick out of the ground or out of the water, and the oceanic crust is the part that's underneath the water.